webinar today. And yep, recording has started. And hello, folks. I'm Noah Gabriel. I'm a project manager with the New Buildings Institute, or NBI, and super excited for this session on packaged terminal heat pumps as an affordable heat pump solution, primarily for multifamily buildings. So with that, we'll go ahead and get started. And just a note here, today's webinar is developed in partnership and sponsored by the San Diego Learn program. The Learn program is a San Diego-based workforce education and training program. They partner with NBI and the Advanced Water Heating Initiative to offer free energy efficiency and electrification webinars. So there are plenty in addition to this one. And if you want to learn more, go ahead and visit the www.sandiegolearn.com website for more awesome informational content. With that, I wanted to provide a brief introduction on why we're here today to talk about packaged terminal heat pumps. So in this webinar, we'll discuss both the advantages and disadvantages of packaged terminal heat pumps, or PTHPs for short. We'll talk about PTHPs versus PTACs, which are packaged terminal air conditioners that you might often see as your heating and cooling system in a hotel. And we're also going to discuss some other applications for new construction as well as retrofits. And lastly, we'll talk about the size of this emerging market. So kind of how many air conditioners they can displace in hotels and multifamily buildings. With that, I'm excited to talk about our three panelists. Jonathan Moscatello is a utility relations manager for Daikin North America. He has multiple decades of heat pump experience and works with his wife on a separate heat pump company, as well as being at Daikin. So that's super exciting. He brings a lot of information to the table and is going to lead us through some of Daikin's product offerings and a bit of the history on packaged terminal heat pumps and some of the differences with packaged terminal AC units as well. Then we have Paul Del Vecchio, who is the president of Ethos Development, which is a mid-market development company based in Portland, Oregon. And he'll talk about some of the implementation of packaged terminal heat pumps in some of Ethos Development's properties. And last but certainly not least, we have Cody Glavey-Weiss, who is a project manager for NYSERDA. And Cody is going to talk about the building development kind of initiative for packaged terminal heat pumps that NYSERDA is working on. And they'll all provide more of their backgrounds and a lot more information, but we're super happy to have all of them here. So with that, I'm going to turn it over to Jonathan to share his screen and talk about some packaged terminal heat pumps. Thanks, Jonathan.
Well, good morning. Well, good morning. To talk about packaged terminal heat pumps. Give me a second to just share my screen. It looks like, Noah, you have to.
Oh, I got to stop sharing. You're so correct. And a quick note, folks, if you have questions, don't put them in the chat, put them in the Q&A, and our panelists will get to them as we can. We'll also save some time at the end of each presentation for a few questions.
Well, as Noah mentioned, I work for Daikin Comfort Technologies, a division of Daikin North America, and I've got a lot of experience selling heat pumps, but today I want to talk to you, of course, about packaged terminal heat pumps, which are a really different product in my world and in my industry, and for a couple of reasons. And so as I tell you about what's happening with PTHPs today, I'll kind of tell you a larger story. But first, a little bit about Daikin. I'm not just trying to, like, let's say promote the company here, but just to give some context to where packaged terminal heat pumps fit into our company and then the industry as a whole. So Daikin is a Japanese-owned company with headquarters in Osaka, Japan, but we manufacture in something like 97 facilities globally. And then we have the divisional sort of organizations that you see reflected on this map. We're the world's largest manufacturer of heating, ventilation, and air conditioning for occupied spaces. We don't really do industrial heating and process site. We just heat and cool rooms that and buildings that people occupy. Um, North America is a relatively new market for us, so we might not be the largest company in North America, but globally we are the largest in units produced and market capitalization. Now, in North America, especially in the residential space, we sell products under the Daikin brand, the Amana brand, and the Goodman brand. All of our PTACs or package terminal heat pumps are produced under our Amana brand. Um, But I want to tell you a little bit about like our, before I dive into those heat pumps, tell you about like what our priorities are as a company. We have a pretty rigorous set of environmental goals as a company. Collectively, they are part of our environmental and social responsibility goals. And to achieve some of those goals, we have truly dedicated our efforts on making inverter or variable speed heat pumps, the necessary controls that are increasingly internet connected and provide services not just to the homeowner, but to other stakeholders. And then, of course, the refrigerant that's used in heat pumps, making sure that that is managed, flowed, and as frankly protected as best as it can from leaking out. And so these are huge priorities for us. These are core technologies and beliefs. We make today our Amana package terminal heat pumps in our flagship Daikin facility located just outside of Houston, Texas. And reflective of our, environmental and social responsibility goals, the offices, not the manufacturing floor, but the offices that are in the facility are LEED Gold certified. And this is a massive facility. It's the third largest in North America, like single level manufacturing facility, which most manufacturing facilities are single level. So there's an airplane factory in Everett, Washington, where Boeing makes their biggest jets. Of course, that's bigger, right? These are huge things. They need a lot of space. And then there's a Tesla factory, which is debatable if it's not as big, but because it's two buildings that are separate, connected by a breezeway, we think that's cheating, but who really cares, I guess. This is where we make our package terminal heat pumps. They're made in America, right outside of Houston. That all being said, I mean, we enjoy our Amana products today have an 80% market share in this space, which sounds like, wow, that's amazing. You guys are doing great. The challenge is that PTACs and the heat pump models are a really small part of our business and the market as a whole. And I want to highlight that point as I talk about this category of products further, because even though we have like this leadership position, it's hard for us to justify all of the necessary investments to bring the package terminal heat pumps up to our vision of very high tech, very inverter or variable speed controlled. And so I'll tell you a little bit about that story. Okay, first of all, the challenge is many of the units that we sell are air conditioner models that have electric resistance heaters in them, which are, I would say, for the purposes of the audience today, undesirable. Yet that's what is being purchased from us. We can't, control what people come to us to buy. And I think that is because PTACs or this product category have traditionally been a very price sensitive product. And most buyers choose the lowest cost option. As with many technologies, building owners often do not pay the power bill for their renters. And so therefore, they don't have that incentive to put a higher efficiency product into the rental property. Or most of the hospitality uses of these products, it varies on whether or not if there are local utility rebates present and Someone's talking to a hotel or motel owner, yeah, we'll see the heat pump models go in there. But in the absence of knowing why one should care, the AC with electric resistance model is often what's installed. So those are some of the dynamics around this market that shape what we make and sell. That being said, like most of you on this call, there's some strong interest in the package terminal heat pump model for use in beneficial electrification. And there's a couple of reasons for that. Well, new construction energy code in most places today produces very modest heating and cooling requirements for the space for that occupied space. Insulation, air sealing are just really good. And so a zonal approach that uses a small capacity efficient heat pump for each of the individual spaces um, is a really energy efficient and low cost way to design a heat pump heating systems for larger buildings. And I think our next speaker is going to give a great example to that. Now, over the years, the heat pumps and PTACs that the PTHPs and PTACs that we make have really improved. They're quieter today, and to the point where the compressor noise, which is different from the air movement noise of machines, the compressor noise is much less today on the models we're making than before. And so this makes a PTHP a low cost option that matches the space, but also something more desirable than it was in, let's say, the years before. We are starting to add controls and options to our PTHP. So, for example, they have a Bluetooth connectivity for out of the box for a separate controller, something like a thermostat that can be placed across the room. And that gives them a more modern way of producing comfort in the space in which they're applied. The controllers can be networked, so for mainly for hospitality purposes, but sometimes for other uses. It's possible to have building controls out of the box with a PTACs, provided that the thermostat that you see on the screen is installed. So all of a sudden, something that was about low cost and maybe not putting an emphasis in occupancy, comfort, and noise and technology is now become quite a reasonably it's reflected more of the modern technology that's available. The other interest for beneficial electrification, aside from I think what we're talking about today, is that there's just a lot of AC with electric resistance, so the PTAC models. There's lots of them out there installed in buildings. And so it becomes more desirable to replace an old inefficient model with one of these more modern, quiet, comfortable, feature-rich heat pumps. And there's a lot of opportunity for states and utilities that are working to electrify with today's packaged terminal heat pump. Um, as I mentioned, like we're seeing PTHPs increasingly as a choice for market rate or mid-market multifamily. It's not just a low cost, but it's a great cost. The point on this slide is that it's about new construction. It's very difficult to retrofit a PTAC into an existing building simply because there's a fairly large penetration through an exterior wall to install the PTHP. And for most retrofit applications, it's while the equipment cost is low, the installation cost is difficult. So that's an existing building problem. But for new buildings that don't have these problems, it's a really wonderful option. It has a low first cost with easy installation. The power requirements and the associated requirements are few and much less than what it would take for a large central system, or even some of the requirements around a ductless heat pump or other kind of, let's say, we call them split systems. PTHPs are highly reliable, easy to maintain, And when it is time for replacement or service, they just simply slide out and slide the replacement back in and plug it into the same plug. So it can be a real winner. Now, the thing that I mentioned before, modern buildings with their great insulation and air sealing, I mean, a PTAC, a small capacity heat pump, maybe several of them in a multi-bedroom apartment, they really do match the need of the spaces well. And so it becomes one of those things from an efficiency standpoint, they become a really good match to the sustainability goals. We have lots of heat pump options available, and we've had them for years. But as I mentioned before, the market really hasn't recognized or supported the heat pump models. So there are not very many of them sold compared to the AC models. But as you can see here, we have models with the new low global warming potential refrigerant. They're available today. We've been making them for several years. They come in a variety of capacities. The smallest is a rated 7,000 roughly capacity, but then there's also 9, 12, and almost 15,000. For today's modern construction, there's more than ample heating and cooling. Now, the units can be purchased with either no electric resistance heat or very small heater kits. So 1.5 kilowatts is roughly 4,500 BTUs, and then 2.5 kilowatt heaters up to 5. 5 is a lot. Like that's equivalent to over 15,000 BTUs. So we hope that people that are applying this are doing a little bit of math to determine what the heating requirements are for the space at the winter design temperature and choosing accordingly. But that's the state of play. We've got the products, we've got them in voltages necessary for all of North America, and we've got them in capacities sufficient for the application, let's say. Now, a little bit of the building science. Where are we today with package terminal heat pumps? Well, if you look on this graph, this is how heating and cooling professionals essentially choose equipment. They look at what you're looking at is a graph on the left is the heating output of a given machine or requirement of the space, depending on what's being graphed. And on the lower, the x-axis, you'll see outdoor temperatures. And so what we're seeing here is a pretty cold environment where we're designing for heating at a temperature that goes down as low as 5 degrees Fahrenheit. This is like Minneapolis, for example, would be a 5-degree winter design temperature. Denver, Colorado is a winter design temperature of roughly 5 degrees. So as it gets colder out, that gray line is the heating requirement of the building. And so sure enough, 5 degrees Fahrenheit, you'll see we need to supply roughly 14,000, just shy of 14,000 BTUs of heating. The red line represents a model of heat pump that might be rated fairly close. It's a 1 ton or 12,000 BTU capacity. But as you'll note, as temperatures drop outside, today's package terminal heat pump really can't keep up with that heating requirement. And sure enough, around 35 degrees or so, we look to electric resistance heat to supplement the heat pump output. And sure enough, down at the lower temperatures, the electric resistance heat is doing all of the heating. That I'd say for electrification purposes is an undesirable view, but it's reasonable today considering that most places don't see that 5-degree temperature but a few hours a year. 1% or so of the heating hours would be at the design temperature. And so the great majority of the heating hours are above 20 degrees Fahrenheit nationwide, even in some of the coldest places. So today's package terminal heat pumps are a reasonable choice for many areas, given the dynamics. However, the future state that Daikin is working for our Mana heat pumps is to have inverter or variable speed technology. And this is, without getting into too deep into the weeds, is the ability of a heat pump to adjust the compressor speed, the refrigerant pressures, and then the air flow over the heat exchangers such that they can maintain a pretty consistent output um, down, as you'll see, into very cold temperatures. Now, this is an idealized graph. So, this is an end state that's idealized, but it's indicative of inverters in general, where a very small amount of electric resistance heat may be needed, but again, only for the coldest few hours. The great majority of all time is spent using the heat pump. Okay, this is my last slide. So with all that said, how do we get to the end state where inverter and variable speed heat pumps become, what's produced for the market? The barrier today, at least in our opinion at Daikin, is that we need new standards for package terminal heat pumps. One that provides the testing procedures and the assurance for customers that there is going to be reliable heat down at those very cold winter temperatures. And so the governing standard for tests and procedures around PTHPs is called AHRI 1310-380. The current standard is year 2017 document. The heating test condition is 47 degrees, so that's pretty warm, pretty standard. This standard is being revised to allow for test procedures for variable capacities. So that will include colder test conditions. And once we have those, we feel like it'll pave the way for inverter technology to make it into the PTHP. It'll probably start as a optional or more high efficiency model. And so developers like our next speaker can choose to invest in a little bit more robust heat pump. And then people who are truly in a price sensitive mode can, or frankly, in a warm climate, might choose to use the non-inverter model. And then over time, we think that inverters will become the standard technology. We'll see. So if you have any additional questions about the heat pumps that we make, the package terminal heat pumps we make, or the technology in general, here's my contact information. And I think that wraps it up for me. Back to you, Noah.
Thanks, Jonathan. That was great. Really loved the intro there and received a ton of questions. So I'm not going to give them all to you right now, but I might let you answer some in the chat after, but we'll take a couple. So one was, can you discuss the condensate drain requirement differences for PTACs versus PTHPs? I think they were especially talking about winter climates, but could be interesting for both.
Yeah, like in the summer, of course, condensate isn't going to freeze. So when it's operating as an air conditioner, we just don't have to worry about that. But in the winter, you certainly do have to worry about occasionally ice buildup on the heat pump and then a defrosting cycle that occurs every so often. And so what happens is you get melt water, and that has to be dealt with. And it really is very dependent on the type of structure that you're located in. And I think in many ways, I might defer that to Paul, and he can talk about how they deal with it. My guess is it's internally piped. So it stays within the structure that meltwater is collected and put into the sanitary drains within the structure. But it's because it's heated pipes within the structure. We don't have to worry or make that anything. My guess is that's what it's.
Okay, thanks. We'll do one more here. You might have already talked about this, but maybe tell us more about the refrigerants used in PTHPs and are there plans to change that for, in coming years based on government regulations.
Well, today, anything manufactured will have the new low global warming potential refrigerant. And we've been making that for 2 years. So for us, we don't have plans to go to any other refrigerant at this time. And it's an end state that no one, I mean, there's people thinking and talking about it, but it's years and years away, over a decade, we think. And so, and of course, the choices that we have available to us have some undesirable consequences, meaning they're very low global warming potential, but they're essentially propane based. And
Totally.
so, you know,
So you
we're
get into
not,
that whole A2L category
yeah,
of potential flammability, right? So it's yeah, there are definitely trade-offs.
that's what we know about refrigerants today.
Sweet. Well, thanks again, Jonathan. That was great. And if you don't mind, yeah, hitting some of the questions in the chat, that would be wonderful.
You bet, we'll do.
Awesome. Okay, well, we'll turn it over to Paul.
Everyone. Paul Delvecchio. Will you give me 1 second to my sharing setup here? Um, so I'm president of Ethos Development. We're a mid-market real estate developer. We primarily build multifamily assets. Um, the mid-market represents a size in both vertical and number of units or size of building. In our market, we work between Seattle and Portland. And typically we're working on infill properties. I'm not sure that it would matter if we were working on suburban to this conversation, but what you'll see here is mostly urban. And we typically build between 5 and 7 stories. So that would be either a wood frame building in our markets or what we call a podium, which is 5 stories of wood over 1, 2, or 3 stories of concrete deck. In Washington, it could be 3, and in Oregon, 2. The kind of the company generally, we have I'd say we're kind of a mission-oriented for-profit company. So we've had some successes with energy efficiency. I believe we built the first all-electric apartment building in Portland. The unlock there is the hot water. It was a very small building, so that was possible. We built a building that ran it was net zero for the core of the building, so it had enough solar to offset the kind of the building's public spaces. It was about 10 years ago. We're pretty enthusiastic about the PTHP product for a couple of reasons. One is cost. It's about half the cost of a ductless split, which would be the likely alternative for our building type. It also does not require any space on the roof, so you're less likely to get leaks, and in the immediate term, because you're not actually putting anything on the roof where the condensing unit would go. They're also a lot more robust, more easily serviceable, and more easily replaced. So they're kind of cheaper to operate from a maintenance perspective over time. We do use wall-mounted thermostats for them, so from the user experience, I don't think that there's much difference there. If not even better, because it wouldn't have a controller, which comes in some cases. So this building here, this is Brooklyn Apartments. It's a 166 unit building in Southeast Portland. Some points to note here. So I think the biggest challenge with PTHPs is how to integrate them into a facade without it looking like a motel. That's, the standard grills can work, but they're not the best. So this example, you can see on the right of the top left image that there's a custom grill underneath all of those windows, and in that is the PTHP unit. So it's proud of the building's actual weatherproof barrier by the manufacturer specification. I believe these are Amana units, so I think they're Jonathan's product through Daikin. We use Amana and LG. But these are rain screen buildings, meaning that there's a gap, an air gap between the facade that you see. That's a weather barrier, and then there's the gap on metal rails, and then the waterproof barrier. That's where our condensate goes in this case. So we just let it drip into that space, and it hits channels and then runs down and gets collected at the bottom, depending on where it is, if it's a landscaped area or not where there'd be people or the ability to ruin the aesthetic of the building, we may just let it drop. Bottom right, you can see what the unit looks like on the inside. It does require a little bit of space. You wouldn't necessarily want to put a piece of furniture right up on it, but we try to locate them in places where that's not a problem. Bottom left is showing you what we're doing in the bedrooms. So in this unit here, this is a 2-bedroom unit. We have this PTHP in the common area, and it's slightly oversized. And we use transfer fans to bring the conditioned air into the bedrooms. So they're sitting, over the door header or somewhere else in the unit. And inside, we use these convection heaters. And we think it's a good product to go with the PTHP. It's an energy efficient product. It's quiet and allows for flexible furnishing. That's the Brooklyn building. The next one here, this is Analog PDX. This building is a 5/2, 7-story building. It's 134 units in North Portland. So there's a couple. I use this one just as a comparison. So this particular unit that's shown here has a ductless split in it, and so this building is a mix. Part of the reason was the facade, as you can see, it's somewhat complicated. Couldn't accept the grills, at least on this elevation. So in the back of the building, we do have PTHPs because the facade straightens out, but on this side we do not. So we have to put the ductless splits in, and I pointed out here at top right what that means. So we have a green roof, but we have less of a green roof because we have these condensing units. So there's several forms of these condensing units around the building. So this is sort of the alternative, about 2x the cost, and I don't think it's functionally really any better. Perhaps a touch of furnishing flexibility. This is the Nomad building in North Portland. It's a 100% PTHP building. So you can see underneath some of the windows there are grills. I think if you weren't actually looking for it, you might not know that they're there at all. It just sort of blends into the architecture. And there are also grills in this building that are housing exhausts, so of various types. So they're being used for different things. And bottom right, you can see the unit. It's again in the common area and somewhat an unobtrusive location. This one here, this is in Northeast Portland, but it's more of a suburban style building, and it's a much more simple installation. So this one has the manufacturer's grills. You can see them top right and bottom left underneath the windows next to the front doors. At this scale, we didn't find it troublesome. And bottom right gives you an idea of what it looks like in the unit. So this has no problem servicing. I think it's a 950-foot 2-bedroom, 2-bath with 2 stories. So it does a great job, and it works in this setting, which I think translates to a suburban product pretty well. Buildings in Tacoma, also called Analog. Just if anyone builds things, that was a mistake. Naming 2 buildings the same thing. We have same deal here, where they're integrated into the facades. In this case, we boxed out underneath just for a slightly cleaner aesthetic, but that's not necessary. They can sit in their own enclosure just fine. In this building, bottom right has forced air cadets in the bedrooms. That was a value engineering or cost related change. They're louder and not as good generally. This is Moraine. It's a higher end building in Tacoma. And this one we did not integrate into the facade. So this was a different attempt at dealing with the grills. Because of the busyness of the facade and its sort of staggered siding and colors, we thought we'd just get away with placing them where they need to be and not worrying about the windows. Top left gives you an idea from across the street, and top right gives you an idea up close. So, I think if you're really looking, you'll see them. If not, it may not jump out at you. The same basic idea. Bottom right is the unit in the living room, and bottom left is the bedroom with the convection heater. And yeah, that's it. From our perspective, these are fantastic products for serviceability and first cost. And I think if you were really pushing to the high end, you might put one into the bedrooms. And if you've done that, maybe it makes sense to go towards a ductless split. But with our construction type and our price point, this works great. It's also worth noting, and Jonathan pointed this out, that they're designed for lower temperatures than you actually see typically. So we only have in our market, there's maybe just a couple weeks a year where you really need air conditioning, unless you live on a kind of southwest facing top higher floor unit that gets a lot more heat load. So I think the primary reason why these are necessary is smoke. We do have kind of a fire season now in the West, and if there's smoke, you can't cool your unit by opening the window and taking advantage of our temperate climate. So the AC becomes a lot more important. So we've been doing them since we started developing, but I think it's now a lot more common than it was. Another option is to put a vent in the building and use a portable unit, but we really don't like that because you're basically putting a permanent hole in the building that's just got two aluminum pieces on one on either side, and putting so much thought into energy efficiency and then putting holes all over the building doesn't seem like the right answer. It also is a lot more intrusive on the interior. So that's our perspective on it. Happy to answer any questions if anyone is interested in the development side of implementing these units.
Awesome. Thanks so much, Paul. That was great. Loved all the pictures of actual buildings there and real world examples. So yeah, several more questions. Do you have a typical strategy for ventilation when using PTHPs?
Well, they draw outside air in through the unit itself. I think one of Jonathan's slides pointed that out. I think the outside air comes in through the outside of the unit, and then it blows at the exhaust out the middle. In the unit, I mean, door undercuts and transfer fans are how we do it. And in multifamily, it's actually designed around opening the entry door with some regularity so that there's air change between the hall corridor and the unit itself.
Yeah, totally. No, great answer there. Sweet. And then I'm just looking through, and I think you also might have answered this one, but just variable or single speed units, depending on situation.
Depending on situation, I think they tend to be single, but
Cool.
I think we have done both. And when you're designing these buildings, I mean that if you're pinched on cost, you will start making changes, and if you're not, you'll start upgrading things. So we kind of use all versions of everything depending on context.
Awesome. And then, yeah, I guess one more here is, have you looked into how much of the heating load in these buildings is being met by the heat pump versus the electric resistance? Experience has shown from other heat pump applications that controls have a big impact on how loads are met.
Yeah, so this is anecdotal, so we don't have any data, but it is absolutely a point worth paying attention to. There's user training involved, and this goes for the heat pump and the convection heater we use. Both of those things need to be left on all the time to work correctly. And a lot of residents, or tenants, don't feel comfortable with that, or maybe didn't receive that information when it was relayed to them, or it didn't stick, when they moved in. So they come home and then turn up the heat, and that's not the point. So it definitely is an issue. I think part of it why we don't see the ramifications of that is that these units are all separately metered for electric. So where the user is bearing the cost of their choices. Sometimes people will tell us that they're not working, it feels cold. And that actually is a good opportunity, because then one of our maintenance folks can explain to them that it's supposed to feel that way. And if you leave it on, it's gonna be okay, and all that stuff. So those are actually good opportunities. But yeah, it is an issue. And I think as they become more prevalent, people will get more comfortable with how they operate.
Absolutely. Yep. No, totally. Behavioral changes are key. So, sweet. Well, thanks again, Paul. That was excellent. And I think there are a couple more questions in the Q&A if you don't mind hitting those. But otherwise, yeah, really appreciate it.
Sure.
And
Oh yeah, okay. Yeah, I'll answer those in the Q&A. Great, thanks.
perfect. Many thanks. Awesome. Okay. And last but certainly not least, we have Cody from NYSERDA.
Thank you. Good afternoon, everyone. Let me share my screen, and I will jump right into it. Okay, perfect. So hi, my name is Cody Glavy-Weiss, and I work for NYSERDA, or the New York State Energy Research and Development Authority. We are really focused on helping New York achieve its fairly ambitious climate goals. And I'm here to talk about kind of what we've been seeing emerge in the New York market, specifically where it comes for packaged terminal heat pumps, as well as a new program that we're launching this year to really try to help spur development of better performance, higher performance units, as well as units that actually meet the needs for owners and tenants, most specifically New York State, but could be applicable a little in other locations as well. So to start with kind of where this story really begins for NYSERDA, it all starts with what we call the original Clean Heat for All Challenge. This was a specific focus challenge that was in a partnership between New York City Housing Authority as well as the New York Power Authority and NYSERDA. We went to demo the replacement, or so essentially for NYCHA apartments, we initiated a demonstration site where a number of apartments within their buildings reused packaged window heat pumps as the distributed heating and cooling solution and replaced the existing one-pipe steam system. Through this demonstration project, we found that there was a 75% reduction in heating energy costs per square foot in just the first heating season. To be fair, it was a little bit more of a mild winter, but once we saw kind of the results coming out of these initial demonstration projects, we realized there's real opportunity here to position packaged window heat pumps as well as packaged terminal heat pumps as a cost-effective solution specifically for multifamily owners who are looking to try to address some of the pressures that are pushing them towards decarbonization. In New York State specifically, we have the Climate Leadership and Communities Protection Act, which mandates complete decarbonization by 2050. And in New York City, we have Local Law 97, which assigns buildings essentially an emissions budget. And if they exceed it, they get fined fairly severely. So multifamily buildings are looking at what solutions can I take to decarbonize right now that don't require a super expensive central plant retrofit where I need to change out all the systems in my building and install a VRF platform. A lot of folks don't have the budget for that upfront high initial cost. They don't have the ability to impact the tenants. It'll cause a lot of tenant disruption over the course of the install. And they're unsure with what the final performance of the system may be. So we're trying to position an alternative solution for multifamily building owners through the form of packaged window heat pumps and packaged terminal heat pumps as a way to, as we said, cost effectively decarbonize without having to commit to expensive central plant retrofits. So to talk a little bit about what we're seeing in New York, we're really seeing that the need for air conditioning, beyond everything else we're going to talk about today, the need for air conditioning is really looking to increase over the next 15 years. We expect New York's climate to become hotter and more humid. Landlords are likely going to be required to start providing air conditioning to tenants rather than just heating. So we're really focused on, and the last point here is, especially with some of the forest fires where smoke is blown over to the East Coast, there's been more of an awareness on the importance of air quality within New York. So we're looking at some of these problems, we're looking at the changes in climate, and we're looking at buildings in New York right now, as well as nationally. So nationally, by 2040, at least 15 million window ACs will need to be replaced, at least once. In New York State, there are at least 500,000 PTACs currently installed. There are at least 900,000 through-wall ACs in New York City alone. And what we're seeing is that buildings built since about 2000, as well as about 40% of new construction multifamily buildings today, are using PTACs with through-wall sleeves as the standard heating cooling solution. So there are a lot of opportunities to try to make the solution work in New York State, just because of the amount of PTACs that are currently installed. So we're really looking to, so by 2040, the state will have a big need for a set of affordable heat pumps that can meet good cold climate performance specs and be installed easily into existing infrastructure. But we're kind of looking at each other and saying, well, why should we wait until 2040 to try to make this happen? So in collaboration, we'll talk a little bit more about this in a minute, but in collaboration with owners, manufacturers, we are looking to really help push forward the development of high efficiency heating and cooling PTHPs as a drop-in replacement for PTACs. We are looking to make sure that these units do not require major electrical upgrades within a building, again, to make them easier to install and more cost effective. We are looking for units that have the ability to improve indoor air quality, whether it's through an ERV block or some other method. And of course, we need good quality of life for the tenants who are actually living in these units. So they have to be quiet. If any of you have ever stayed at a cheap motel like myself, you'll know that when you turn on the PTAC that's in the window, it can be loud. So we definitely don't want those in people's apartments. So we're really looking, how can we help push forward development of these units and get them into New Yorkers' homes as quickly as possible? So I'm not going to spend too long on this slide because I kind of just laid out our objectives, but overall, we're really looking to drive innovation of high efficiency cold climate heat pumps that are coming about as a result between close collaboration between HVAC manufacturers and New York State building owners and operators. Some of the major points, as noted, is it has to be compatible with existing infrastructure. If you need to make expensive changes to your building envelope, it's just like not going to be possible. Kind of like Joe said, if you don't have an existing penetration through that wall, it is not cost effective to put a lot of holes in your building just to install this as a solution. So we're really looking to target buildings that are currently using PTACs, where a PTHP could be a drop-in replacement, or new construction that is planning around PTACs and trying to get them to use PTHPs. We're looking for flexible solutions for installation, maintenance. In a lot of cases, now that these units are in tenant spaces, the tenants will need to provide kind of the ongoing operational and maintenance changes to the unit, whether it's filter cleaning. And we're looking for flexible condensate management solutions. This is going to be a big issue, especially in climates like New York State, where it will freeze in the winter. How do you deal with that condensate? Some buildings are fortunate to have a two-pipe steam system that they're retrofitting off of, so they can pipe the condensate into the steam condensate line. Buildings that don't have that are a little bit more kind of looking for a solution. What we found under the original Clean Heat for All challenge is the two manufacturers who participated in that challenge, Gradient and Midea, they used atomizers for condensate management, where they just misted condensate outside whenever it filled up the drain pan. Their solution has been mostly successful. There have been some teething issues since this is a relatively new way to try to get rid of condensate, but it has been relatively effective at the demonstration site so far. So moving just on to kind of explaining the 4 core components of our program. One, this all kind of starts with manufacturer and owner partnerships. If owners and tenants' needs aren't being met by these units, and manufacturers are not interested in developing these units, then the program kind of goes nowhere. So we've been working with a number of manufacturers. We've been working with a number of building owners, both large and small in New York State, to develop a technical spec for the units that they're most interested in seeing in their building. And we've been working with manufacturers to try to fund development of these units, which leads us into kind of the second core component of this program, product development. The program just closed a competitive solicitation where we're making available up to $10 million to manufacturers of PTHPs to develop units that meet a published NYSERDA spec, and I'll talk about that in a second. We are also awarding funding for field demonstrations, where we will look to provide up to $1 million per awarded product to building owners looking to demonstrate these PTHPs that are developed under the program in their buildings as an effective solution. The last component of our program is we are hoping in end of 2026, early 2027, we are going to be looking to run, assuming everything goes well, we are going to be looking to run an early adopter version of this program where we'll provide more of a midstream, upstream type incentive to PTHP manufacturers directly to get their units deployed in the New York market. This is, I'm just going to breeze through this slide because this kind of just lays out how the program kind of works. But in a nutshell, we're working with awarded manufacturers on the units. We're working with building owners to qualify potential demonstration sites. We're going to hope to connect a network and connections between these two parties to fund demonstration projects where these units are actually installed, and we can collect real-world performance results on how these are doing in New York State multifamily buildings. I'm just going to run through the 3 types of PTAC that we are interested in finding PTHP replacements or solutions for. One, the classic PTAC. This is what you see in a lot of hotel rooms. Typically, they will have either gas or electric resistance heating, and they may be on 240, and they may be on 240 volts. This is a unit that there are quite a lot of in the country overall, as well as in New York State. And this is the first type of PTAC that we are really looking for PTHP replacements for because it's just so common. The second, this is a little bit of what we call the New York City special. You don't find this in too many other places throughout the country, but we have a lot of them in New York City, which are hydronic PTACs, or these are PTACs that don't have any electric resistance or natural gas heating built in, but they do have the ability to be compatible with a hydronic coil that they can essentially just blow air across for heating. So these are for New York City buildings that may have steam heat off of the Continental District steam or their own steam boiler or hot water heat. And it is kind of like this halfway solution for New York City buildings where you can get the benefits of air conditioning, but you don't need to rely on electric resistance heating in the winter. So we are looking to address these units as well through this program. And then finally, we are looking at through-wall ACs. These are typically about half size of the first 2 categories we've talked about, only about 14 to 16 inches. And these will not have heating typically at all and will typically run on 120 volts. We are looking for PTHP replacements for this category of unit as well, because there are quite a number in New York City, at least 900,000. And while this may not be a traditional kind of application for PTHP replacements, we do think that manufacturers out there can bring compelling units to market that do fit into this form factor. And it could be a really good option for buildings that are looking for this distributed decarbonization solution. Just to briefly overview, as we said, we really worked really hard to make sure that NYSERDA as a state authority wasn't kind of just like choosing a set of technical specs out of thin air and then making owners or manufacturers comply with them. We really wanted to build the spec from the ground up. So we worked with a number of manufacturers, a few of the more involved ones listed here, including our friends over at Daikin, thank you. And we've worked with a number of large New York State portfolio owners, Empire State Realty Trust, LM Development Partners, Equity Residential, to really inform the requirements of what these units need to do and how well they need to perform. We have our spec, full spec is published online, but to call out some of the key criteria for what we actually developed in this area. One, as I've said a couple of times, the units have to be compatible with existing infrastructure. So that means, they can't be some weird custom size where no existing penetrations match. And ideally, they cannot require electrical infrastructure upgrades, especially when we're looking at older buildings in New York. One of the big barriers here to decarbonization is each individual apartment just doesn't have a lot of capacity. And they may be limited, to 120, 15 amp circuits. So these units need to provide an ability to be compatible with older building stock, because if you have to replace all of your electrical risers, then that's going to be as expensive as doing a central plant retrofit. We are looking for high efficiency, of course, for cold climate performance. We are looking for a seasonal coefficient of performance of at least 3, CO2 of at least 18. As was kind of highlighted earlier, an emerging field in PTHPs is we're really looking for 100% heating capacity down to 5 degrees without electric resistance heating. This is one of the things Jonathan was talking about earlier, where this is kind of the new trend for PTHPs, maintaining high capacity down to cold temperatures. We're even going to try to push this a little bit more to say 100% down to 5 degrees, but we'll see what manufacturers are able to develop and provide. Finally, as noted, they need to be quiet and they need to provide dehumidification. So my last slide is just briefly to talk about kind of the timeline that we're working on here in New York. As of right now, manufacturers have just finished submitting their proposals to our competitive solicitation, and we are continuing to engage owners in some of the initial units that are going to be developed through this competition. We are expecting that next quarter, early Q2, we will be able to announce awards to manufacturers that have been qualified to develop these new units, as well as launch a qualification for building owners to actually get their individual buildings qualified as demonstration sites. We are expecting in Q3 to actually start seeing demonstration teaming occur, and then hopefully by Q4 for this heating season, if possible, we would like to see some demonstration projects actually start taking place. So we have an ambitious year ahead of us. As probably the biggest thing that folks may be interested in will be the units that are actually awarded through the solicitation that is running right now. So as noted, this should be announced in Q2. So keep an eye out for some of these announcements. And that's basically my presentation. If you have any questions on anything I talked about today, please feel free to reach out to us at pthpprogram@nycerta.newyork.gov, or give me a call at the number below. Myself and my colleague Brett Weiland run this program, so either one of us will be able to give you the information that you need.
Thanks a ton, Cody. Awesome job, and really excited to see what comes out of this exciting program. Have a few questions in the chat here. A few folks were asking about costs. I know that's kind of hard to speak to, but do you have any kind of goals, or at least, I guess, maybe comparisons to, traditional PTAC units, right?
Mm-hmm. Yeah, so this is something that we will have information on soon, but I cannot publicly state it yet. So as noted, our competitive scoring committee is happening right now. This should be done in the next 2 weeks. Until that committee finishes, we can't actually publicly say anything, but we are reviewing costs from vendors as part of this proposal review. So very soon, we will be able to share some estimated information on initial costs, but unfortunately not today.
Awesome. And yeah, some of the other questions were also about, testing and everything, but I'm sure we'll get more information on that soon as well. And then I guess we'll finish off with this last question. In today's environment, do you anticipate supply issues? So it seems like maybe you could speak to previous programs, right? Or is there any supply issue with the window units previously tested?
Mm-hmm. So to be perfectly honest, the NYCHA project only tested about 30 window heat pumps. So it was not like, thousands of heat pumps in this initial round. So at least for this initial demonstration of the NYCHA program, supply was not an issue. Out of the two companies that participated, Gradient is a little bit of a newer company in the sense that, they're not as established as MIDEA and their production capacity is a little bit less. So we've seen MIDEA be a little bit more successful at scaling up. And Gradient's working on it, they just don't have the size. So we are keeping focused on what potential supply issues may arise, and we're going to try to provide additional funding to manufacturers to remediate that as we see it occurring. So yes, it is something we are thinking about. It definitely could happen, but hopefully we can, try to fix that a little bit.
Wonderful. Okay, well, thanks again, Cody, and thanks to Paul and Jonathan as well for a great webinar. So yeah, we will be sending out a PDF version of the slides, and this webinar is also going to be recorded and posted on YouTube. So yeah, just a huge appreciation again to all the presenters, and thanks to the audience for many great questions as well. And we'll see you at the next webinar. Cheers, y'all.
Thanks, everyone.
Thank you, everybody.
Thanks, everyone. See ya.
Thank you, everybody.